Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to talk a little bit about Young's double slit experiment and what properties of light this was able to prove. So first of all, when we have light approaching two slits and we want to see how that light is going to be displayed on the opposing wall, a lot of times at first glance it's easy for us to think, well, if light passes through here, then in theory the bright spots that we would have would just be directly across from those openings, right here, and everything would be blocked. And so that's what Young wanted to test and prove, is to see whether or not that was actually an indication of the properties of light. And one thing we want to appreciate is that light, as we now know, is going to have these wave properties. And so it's actually these waves of light approaching these openings. And if we think about it in terms of water, so if you imagine like a pool that has a little jet in the wall, and when the jet is turned on, it's pushing water, but it doesn't just push in a perfectly straight line. So for a pool, you wouldn't expect to see that when that jet is on, it has a little ripple in the water just in a directly straight line right to that opposing wall of the pool, and nothing else gets disrupted. Right? In a pool, we would expect that when you turn on those jets, we actually notice that seemingly all of the water is impacted. And the reason why is because of these wave properties. So if we were to extend these out, and I'm going to do just a quick messy version of this, I'll clean it up a little bit, but you can see that these waves would overlap with each other and impact each other. So the way that the ripple in the water looks as you have these waves traveling through and at slightly different angles all around, they're going to run into each other. And so we can see that it's way more complex than just to think that when we have two jets turned on in a pool that they're going to create a ripple effect in the water in a very straight line across to the opposite wall. So we know that there's going to be a level of complexity here, and we want to understand what that looks like and then how that's indicative of the wave properties of light. So first of all, let's talk about what we're drawing here. When we draw, let's get rid of all this, and then let's talk about what this is. So when we see these lines here for a wave, if we relate this to what we're used to seeing for wavelength, which is, if you look from the side, we're used to seeing wavelength look something like this. And so those peaks are what's represented by the lines that we draw. And then what's not drawn here, but if we think of in between, so these little spots here in between would represent these corresponding valleys in our wave. So you have peaks and valleys, peaks and valleys. So as you look at how these waves are going to relate to each other, let's talk about how those peaks and valleys might impact each other. And as I draw this out, and I'll try to draw it, it's going to be freehand, so it might not be perfect, but it'll give us at least a good enough understanding of the properties that we're seeing at work. So we're going to have two types of interference when these waves run into each other. So we're going to have constructive interference and we're going to have destructive interference. And we'll talk about how each one can impact the other wave. So if we think about just the meaning of those words, constructive, sort of building something, right? They're coming together. Destructive, breaking something down, destroying something, destruction. And so if we look, we'll see how these constructive and destructive properties are going to relate to these two waves and their impact on each other. So when we have the parts where we have the peaks coming together, so where you see these points of intersection, and sometimes what you'll notice, and if I had drawn this out perfectly, but you'll notice they oftentimes will form a corresponding line. So that's constructive interference. It's two peaks. It's two of the greater amplitudes of your wavelength at the same point, and they are going to come together. So if you look at that opposite wall, when evaluating light properties, you're going to see that you'll have a brighter section because of that constructive interference. And so you'll see that here, and sometimes you might see it at an angle where they align. So here you might have like a bright spot there, and here you might have a bright spot, as you follow these, maybe out here, and then here another bright spot if you follow where you see these points of intersection out here. And then in between those areas, so in between where we have those points of intersection, or in between where we have constructive interference, that would be where we have destructive interference. The waves are essentially canceling each other out or reducing the magnitude of the wave. And so for those sections, you would see darker portions. So as opposed to what some might think with light passing through two holes, that you would just see two bright areas directly across from those holes, here we actually notice that you see that these areas don't really correspond to the brighter areas being directly across from the slits in the surface, and that's because of the complexity of the constructive and destructive nature of these waves. So Young's double slit experiment allows us to appreciate the wave nature of light and proves that light is experiencing wave properties because we have constructive and destructive interference explaining where the light and dark portions fall on that opposing wall. For more, please check out our other videos, and thanks for watching.